Welcome, everyone. It's a pleasure to be able to contribute to this important conversation at COP28 about the technological capacities that are needed for climate impacts research. My name is Alicia Karspeck. I am the Director of Earth Information Programs at SilverLining. I'm delighted to give you just a brief introduction to our Cloud for Climate initiative. Having spent my research career as a climate scientist and modeler, I know firsthand how critical Earth system models are as a tool for predicting and managing the impacts of climate change. Comprehensive Earth system models, which operate on planetary scales, are just one type of model that we need for understanding impacts. We also need models that tell us how things may change on the more human scales, like whether we'll experience more intense flooding, or how hot our neighborhoods could become. Models, as well as the data sets that are produced by them and the high-performance computers needed to run them, are the primary tools that we have to understand and predict our climate future. But to use them effectively requires a foundation of specialized training, which opens the door to being able to participate through having a voice in science and policy, and ultimately being able to help our local communities plan for the future. All of these aspects are important, ranging from foundational education all the way to participation in the global dialogue around climate. In the Cloud for Climate program, we put our focus on addressing the technological barriers to participation in climate research. Of course, there are many technical challenges to using climate and adaptation models. Geophysical models are notoriously difficult to use, requiring specialized software engineering and disciplinary expertise. They typically require specialized supercomputers as well, available to very few researchers outside of the wealthiest countries. And of course, they generate very large data volumes, which can be difficult to access and analyze. One of the hypotheses that we have at SilverLining is that cloud computing and storage on the public cloud can help with some of these challenges through democratizing access to high-performance computing and allowing research and analysis to be done without downloading massive amounts of data. And so our mission at Cloud for Climate is to accelerate humanity's ability to respond to the risks of climate change through expanded access to climate models, climate data sets, and the necessary research tools. So what is it that we do? We support the creation of new climate data sets with open access through the public cloud. We have helped make hundreds of terabytes of climate data available on the AWS Open Data Platform. We also work to reduce technical barriers to running Earth system models and other climate impacts models on the public cloud. And we engage in capacity building in the Global South, supporting the adoption of cloud-based analysis tools and services for climate research. Just as an example of our capacity building, this fall we hosted a workshop on running the Community Earth System model using cloud resources from AWS at the WCRP Open Science meeting in Rwanda. The technical aspects of the workshop were led by scientists at the National Center for Atmospheric Research, located in the United States. We had representation from nearly 20 different countries, with the majority of participants coming from outside the US and Europe. Gender representation was also excellent, with nearly 40% of participants identifying as women. We also had a productive mix of researchers from both early, mid, and senior stages of their career. So let me just close now with a vision for our future, one where models and data sets and computing can be brought together with training, capacity building, and the necessary research funds to help give Global South researchers the technical resources they will need for managing climate impacts in their own communities. Thank you very much.